Here we have a right angled triangle. We are interested in angle A in this right angled triangle. The side that's opposite A is over here. The hypotenuse of a right angled triangle is opposite the 90-degree angle. The hypotenuse is the longest side of a right angled triangle. It is opposite the largest angle. The largest angle in a right angled triangle is the 90-degree angle. The other two angles are always less than 90. The three angles in a triangle have to sum to 180. So these two angles must sum to 90. So both of these angles are less than 90 degrees. Now, the short side that is next to angle A is called the adjacent side. Adjacent just means next to. So when we refer to the adjacent side in a right angled triangle, we are referring to the short side that's adjacent to the angle. We are not referring to the hypotenuse. Now, we have these ratios, sine of A, cos of A, and tan of A. The sine of angle A is defined to be the side opposite A, this side here, divided by the hypotenuse. I will show the values in a moment. The cos of A is defined to be the side adjacent to A divided by the hypotenuse. Finally, the tan of A is defined to be the side opposite A divided by the side adjacent to A. Now, in this picture, A happens to be 18.51 degrees. The side opposite A is 4.17. The hypotenuse is 13.12. So the sine of A is 0.32. So I can change this triangle, and now the sine of A is 2.18 divided by 6.85. You can see that it's still 0.32. So as long as we don't change this angle, the sine of A is unaffected by the size of the triangle. And the same, of course, is true for cos of A and tan of A. So the size of the right angled triangle makes no difference. It's this angle that counts. So as long as we keep this angle at 18.51 degrees, the sine, cos and tan of it are unchanged. Now I just want to mention the sine, cos and tan of this angle up here, which I'm calling angle B. To find angle B, we just add angle A onto 90 degrees, subtract the result from 180, and in this case B is 71.49 degrees. To get the sine of B, we need to take the side that's opposite angle B, because sine is opposite over hypotenuse. Now the side that's opposite B in this case is this side here, and divide by the hypotenuse. The hypotenuse is 11.94. That doesn't change. So it depends on which angle we're talking about. If we're talking about B, then this side is the side opposite B. So we have to take 11.32 and divide by 11.94 to get the sine of B. But that's the same thing as getting the cos of angle A. The side adjacent to A, 11.32, is the same as the side opposite B. So we see that the sine of B is equal to the cos of A, and we know that that's 0.95. Now let's look at the cos of B. To get the cos of an angle, we need the side adjacent to the angle. That means the short side adjacent to it, not the hypotenuse. So here's the side adjacent to angle B. And we need to divide that by the hypotenuse. Cos is adjacent over hypotenuse. Okay, so that's 3.79 divided by 11.94. But that's exactly what the sine of A is. So the side adjacent to B is the same as the side opposite A. So the cos of B is the same as the sine of A. In this case, that's 0.32. Finally, we have the tan of B. So the tan of B is, well, tan is opposite over adjacent. So the tan of B is 11.32 divided by 3.79. But that's the same thing as turning this fraction here upside down. So that's the same thing as turning 0.33 upside down. So, 1 divided by 0.33 gives us 3.03. 1 over tan of A is sometimes called cotan of A. COT is short for cotan. So these relations hold when angles A and B add to 90 degrees, as they do of course for this triangle. Now in the next video I will prove that these ratios, opposite over hypotenuse, adjacent over hypotenuse and opposite over adjacent, remain constant no matter what size the triangle is. So we will prove this by considering similar triangles.